To take a few steps and to pick up a glass of water and to take a drink of it requires that the brain understands the configuration of all the major bones in your body and the tensions in perhaps 100 muscles, and second by second, but much faster than that, it has to control and send impulses to each of those muscles to ensure that you take some steps to avoid obstacles and not fall over, lift the glass to your mouth and to take the drink. The robots that are simulating human movements, humanoids if you like, use very fast computers because the calculations required to do what humans do almost intuitively, it requires incredible computing power. Now our brains don't have that same computing power, so how do we do it? Well, we simplify the complexity and, if you like, we build a mental model which is continuously updated that allows us to move from place to place. Now, people test in many different ways. My thesis is testers think in similar ways. The patterns of thought, I believe, are similar and I think portable across the different approaches that we have to do what we call software testing. The new model is a model of how testers think. Do you remember in the film The Matrix when Morpheus was teaching Neo how to be the one and do remarkable things like leap off tall buildings and so on? Well, he said to Neo, free your mind. And in the same way, I want to suggest that you need to free your mind of extraneous details, because what we're going to do is create a model of how you think. So I want to strip away all the stuff that gets in the way of your testing thinking. So with that, I want to suggest that you forget, for the time being, logistics. And I'll explain what logistics are, but the way I'll present this is I'm going to suggest that I don't care. For the next few minutes, I don't care whether you document your tests or not. That's not testing, that's logistics. I don't care how you run your tests, whether you are using an automated tool or you're doing it by hand or some other piece of magic. I don't care what approach, software development approach you use, whether you're agile or waterfall or something else. I don't care what business you're in. I don't care what technology you're using. All these things are logistics, and I want to suggest we put those to one side. They're really important, but for the next few minutes, I want to suggest that you forget them and put them out of your mind, just to free your mind, to clear your mind. Now, I want to say two things. The first one is all testing is based on models. And I've already said that implicitly in the last video on models and modelling. The second thing I want to say is all testing is exploratory. And let me explain what I mean. Essentially, our mission for testing is we explore sources of knowledge. We gather information from documentation, from people, from the old system if it's available, from the new system if it's available. We also use our existing knowledge and experience, but also part of the information we bring to bear are our prejudices and biases. So it's a bit of a mishmash of stuff, and we have to make sense of this complexity. Now, the way we do this is we build mental models. Now, mental models, I'm going to suggest that they are literally our understanding. So our understanding is based on the models we make in our head. Now, we might write these down, or we might be given some models to actually make use of, but that's logistics. I'm not worried about whether they're a mental model or they're a documented model. That's not the point. That's not testing. That's logistics. And then when we're comfortable, we have a good understanding, that is, our models are acceptable, they help us, we use those models to inform our testing. Now that's the kind of message or the mission from the mountaintop. I want to come halfway down the mountain and explain the two modes of activity and thinking that we have to get involved in. Now, the first thing we do is we explore. We explore our sources of knowledge, our sources of information. And what we do is we create test models. Whether we document them or not, I don't care. That's logistics. Now, at some point, we believe our models are adequate. They're good enough for us to test the system under test. And by adequate, I mean we believe we have a good understanding of what the system under test should do. That is, the requirements, user stories, the old system, whatever source of information we have. We believe we know enough to create meaningful tests. Now, what happens very often is when we start to test the system itself, we discover that our models aren't perfect. And so quite often we have to go back to exploring our sources of knowledge. We have to go back to the users for clarifications, or we find anomalies in requirements which we want to check with the users maybe to let them tell us what the system should really do. Now, in order to do this, we have to use our judgment, because very often our sources of information conflict, or they're ambiguous, or there are gaps, of course, always gaps. So we have to use this thing called judgment to say whether we understand in enough detail, with enough certainty, what the system should do before we can move from the left, exploring, through to the right, which is testing the system itself. So this left and right, I'm going to kind of use that to describe the two major activities, the two major thinking activities, if you like, that we adopt in order to do this job we call testing. Now, as a footnote, I just want to add that developers explore and test in a similar way. They access the same sources of knowledge in order to build the software they need to build. But they also use those models that they use to build the software to test. Now, in some respects, that's one of the reasons that developers often don't make good testers of their own software, because the assumptions they make in their mental models to build the software, they carry over into testing quite often. It's very hard to not take those assumptions over. But that's an aside. So what I want to do now is go into the detail of what the model actually looks like at the lowest level. So we're at the foot of the mountain now, if you like. So on the left, we're exploring, and what we do when we explore is we inquire. I've got this verb, inquiring, and by inquiring I mean we read documentation, we interview people, we ask their advice, we look at the old system, we look at the new system if it's available, and so on. So inquiring is the activity of gathering that information. And as we gather that information, we have to make sense of it, and we create mental models. We do modelling in our heads. Again, we may write those models down or not. I don't care, because that's logistics. Now, I've said before, models are our understanding. So wherever I use the word model, you can substitute the word understanding, in my opinion. It is the same thing, literally. Now, when we have a model, we can use that model to make predictions. We can predict what the system should do in a certain situation. So if we see anomalies in our requirements, we can make predictions, and we can use those predictions to challenge our sources. That is, we can go back to our users and saying, is it correct that if I enter A, B and C into the system, that the system should do D, E and F? So we have this notion of prediction from our models to predict outcomes of behaviours of our system under test. And we've got this notion of challenging our sources, going back to the users typically to ask them, have I got this requirement right in my head? Have I understood the requirement correctly? Or I found an anomaly in the requirement. Can you advise me what I should do next? So we have this process on the left-hand side of exploration involving 4 activities: inquiring, modelling, predicting and challenging. Now, when we're comfortable that our model is adequate, that is, I know enough and I know with some certainty what the system should do, I can move over to the right-hand side. So I'm going to slide this slide over to the left. And the models I've got, okay, I'm going to use those models to test. Now, what I use those models for initially is they inform my testing. That is, if my model is, say, a flowchart, It may be a flowchart through the business process if I'm doing acceptance level testing, or it might be a flowchart of the processing flow within a piece of software, within a piece of code. It could be a model such as a state transition diagram, or it could be a sequence diagram, or it could be a collaboration diagram, or anything. It could be a checklist of things to cover, simplistically. But those models give us an idea of what we should cover in our testing. So the notion of coverage comes from our models. Now, when we apply those tests, whether we run those tests by hand and by using our critical faculties to observe the behaviour of software, whether we use a tool or some other piece of magic, I don't care, but we apply those tests. We stage a test, we capture an expected and an actual result, and make a comparison and judge whether there's a pass or fail, if that's the game we're in. And when we get the responses from our system and we recognise the behaviours as valid or anomalous, we make an interpretation. What am I learning when we run this test against the system under test? Now, when we see an anomaly, usually we log it in some kind of defect log or bug report or an incident tracker, that kind of thing. And this isn't part of the model, but when we log bugs, we trigger a change in the system from developers who obviously diagnose and fix the bug, and then they release a new version. And the system under test, we then reapply our tests, we reinterpret the results. Now, of course, we report progress to our stakeholders and help them to understand what the system can and cannot do so they can make their decisions. But we also have this notion of sometimes when we test, we learn that our model isn't quite right. So we have to refine our models before we get our testing just so. In that our meaningful tests might reveal issues in requirements that we didn't understand, or at the extreme is we may have to go back to the users. And we've all experienced this, where we run a test and actually our understanding of the requirement may be with some certainty we know what the system should do. The system doesn't do it, but it looks like the requirement itself could be anomalous. So very often we have to go back to users right to the beginning, to our source of knowledge, to challenge the users and saying, the system does this, it doesn't match the requirement as I understand it, but it may be correct. Can you advise us? Now, when you glue the two halves of the picture together, you get this, what I call new model testing. It's a description of the thought processes we go through as we do this job called testing. From the left, where we're inquiring from our sources, gathering information, right the way through to reporting and logging bugs. Now, I want to explain in a little detail what the new model is and what it is not. I don't want to give you the wrong impression here. It's not a process. It's not a process to follow from start to finish. It doesn't have inputs and outputs, procedures, entry and exit criteria, that kind of thing. It's not something to be followed in that way. It's a map of the different ways of your thinking, the different states of your thinking as you test. And that's what it's offering to you. It's a picture of the different modes of thought that you go through. It doesn't tell you what to think. Now, interestingly, what I've learned through talking about this for some years now is our brain quite clearly could be in a different state for several features that we're trying to test. So for one feature, we might still believe the requirements are unstable and they need clarification and sorting out. But for another feature that we're also looking at right now, it might be our model is good, our understanding is good. Yes, we can create some tests and run them. And then in another feature, we might be thinking about, oh, wait a minute, we've learned something today that makes us think the requirements need more attention. So depending on where we're at with our testing of various features, we might actually have different modes of thought at the same time. And this can't be represented on a traditional process flowchart, can it? Now, it's a model, it's wrong, but I believe it's useful to do certain things. What it does is it suggests how we think. It doesn't suggest what we think. It's not providing any detail of or content of the thoughts we actually have when we think. It's just looking at the modes of thinking, the states of thinking that we go through. It helps us to understand what we need from logistics. So I use the model to explain, for example, what test execution tools can do for us. They help us in the applying section of the model. Now that's one activity out of 10. So there are 9 activities that test execution tools do not help us with, and we still need almost all of them in order to get value out of test automation tools. And so it helps me to explain what automation can and cannot do for us. So I use the model in many ways nowadays to explain stuff, and you'll see me using the model to illustrate how many of the terms and explanations I'm going to come up with in future videos, it's going to help me to give you a better understandable explanation. Now, I've been talking about this model for about 8 years now, 2014 or so, and I've presented it at conferences, many conferences over the years, and I've probably presented it to thousands of testers. Now, I always ask people to challenge me and say, look, does this model help you or hinder you, or what does it say to you? And do you have any criticisms or comments that you think might help me to refine it? And again, I've not experienced criticism for it. I still look for it. I still want people to try and find holes in it. But the biggest comments and the biggest criticism I've ever had, and I've had it many times, is people might say, it's not new. And by that, I don't mean it's 8 years old. It's not new in that regard. It's not new to me as the tester, which makes me think that actually I might have got something that will actually help you, in that if it's not new, I must be getting closer to the mark and closer to the understanding of what's going on in your head as a tester. So in that way, I'm reasonably confident it's going to be helpful to me in the future, and I hope it'll be helpful to you. If you want to know more about the concepts I'm talking about in the Glossary of Terms videos, it will probably help you if you take a look at the Leadership in Tests online class that I created a year or two ago. It covers some of the topics in more detail and obviously provides more of a structured approach to explanations of the concepts, and also gives you some idea of how to do some of the things that I talk about. I hope you can take a look at it and get value out of it. The link is below, bit.ly/leadintest.